introduce you what is AMET and what we are now. As you all know, AMET is well known for maritime studies. It is India's first maritime university for marine-related training, education, and research. AMET is thriving in this field for the past 2 decades and producing quality marine engineers and captains to the shipping industry. It is a NAC accredited de novo category deemed university, and it has 14 UG programs, 6 PG programs, 14 PhD programs, and 7 diploma programs in marine and other disciplines as well. It offers marine engineering, nautical science, naval architecture, graduate marine engineering, ETO, etc. In addition to it, it offers AICTE approved programs such as mechanical engineering, mining, petroleum, and food processing technology. Currently in AMET University, there are more than 3,000 students are pursuing various programs ranging from diploma to doctoral research. So far, AMET has trained more than 500 international students across the globe. The countries like Republic of Nigeria, Angola, and Djibouti have signed a long-term memorandum of understanding with AMET University to develop their human resources in maritime trading. Companies like AP Moller Maersk, Goodwood, NYK, and many more shipping giants are visiting AMET University frequently for campus placements. The Department of Mechanical Engineering is one among the prestigious school of AMET University. It was established in the year 2014 with a sanctioned intake of 120. It has qualified faculty members, state-of-art laboratories, ICT-enabled classrooms, and skilled support staff members. It offers BE Mechanical Engineering, ME Thermal and Fluid Engineering, PhD in Manufacturing, Thermal and Design Engineering. The Department of Mechanical Engineering is practicing all new and innovative techniques for teaching learning practices for producing industry-ready engineers. Yes, now we are coming to the topic of today's discussion. It is a current topic as well. Advances in composite materials machining, that is synthesis, manufacturing, and optimization technique, synthesis, machining, and application is a current topic of the today. Almost composite materials is everywhere. It is being used by almost all industries today. All kind of industries are using composite materials. It has created a great revolution in the materials and manufacturing process. Today, the aircraft industry is one of the major consumer using a variety of composite material in its structure. That is why many researchers are still continuously doing research in this topic, that is composite materials. The greatest advantage of the composite material is less weight and competent strength. Less weight, competent strength. The only problem that is persisting in the composite material, that you know very well because you belong to that category. I mean, you are all doing research or you are all continuously in touch with the composite material. So I don't want to say, because our speaker is also going to speak about that. He will give you more great insight in this particular thing. Before that, I want to say a few things about this. See, the greatest notion behind today's workshop is to give, already this is known topic, but what we are going to give new. The research is continuously growing. People are doing research on composite material in different dimensions. So this kind of workshop is going to tell you is going to open a new avenue or a new path to reach your solution or to reach your problem or to give a solution to your problem. So I request all participants to participate fully without diversion, because this kind of workshop definitely gives you enough information or more than sufficient information, and that may help you to complete your research successfully. So thanks for this opportunity. I once again welcome you all, and I request the organizers, the organizing committee, to keep our participants engaged. And thanks for this opportunity. Thank you all. Over to Tanigachalam.
Vijay sir? Vijay? Okay. Thank you, sir. Thank you for your introduction talk about that FDP. Unfortunately, today our chief guest, Dr. M. Uday Kumar, his father is unwell. So due to small changes in the first speaker, today our first speaker, Dr.V.Arumugaprabu.
Welcome, sir. And Prakash is also there. Prakash is well known to me.
Good morning, sir.
Good morning, sir.
Thank you, sir, for your welcome.
Small introduction. Vijay, can you give a small introduction about it? Vijay? Vijay?
Yes, sir.
Okay.
Yes, sir. Yes, sir.
Okay.
Yes, sir. It gives me immense respect and happiness in introducing our guest for the day. I would like to introduce our guest, Dr. V.Arumugaprabu, Associate Professor, Department of Mechanical Engineering, School of Automotive and Mechanical Engineering, and Deputy Director of IQAC, CLT of Kalasalingam Academic of Research and Institute. He completed various funded projects. He has completed 4 scholars for their Ph.D. and at present he is guiding 6 scholars towards their thesis. He has published more than 40 conference papers in different countries including Malaysia, China and South Korea. He is also acting as an editorial board member for more than 5 international journals. He is also acting as a reviewer for several international journals. Now, I would like to invite Dr. V.Arumugaprabu, Associate Professor, Department of Mechanical Engineering, to deliver the session. Yes, sir. Please, sir.
Yes, thank you, Vijay sir, for your introduction about myself and respected Professor Karthikeyan sir, HOD Mechanical Department, and respected conveners of this faculty development program on advances in composite materials, manufacturing process and optimization techniques, and all the faculty members, research scholars who are here to participate in this 2 weeks online FDP program. A very good morning to all, and I am very happy to be a part of this FDP in sharing my research knowledge and my research activities that I am doing actively in this particular area of composite materials. And the importance of composite materials already our HODs are pointed out in a very crisp manner how much more needed in today's scenario, especially these composite materials, and why more research focuses towards these materials, because the conventional material is fully replaced by means of these composites. So this material's importance is always existing in the future also, and more researchers, they are focusing on developing some innovative kind of material which possess some interesting properties. So with this brief layout, let me move on to the discussion about that topic that I have chosen for today's faculty development program. Let me share my screen, and I hope all of you have a very good knowledgeable session in terms of getting an idea about one new type of composites that is purely based on the filler. So today's topic that I have chosen for this 2 weeks online FDP program is about the importance of fillers in advanced composite manufacturing. So we all basically have an idea about what is composites, what's the need for composite, what's the special characteristic of composites, and what are all the different types. So the types is going in an exhaustive manner in case of the usage and the development of composite material. Why? The reason behind that is because of the enormous applications. That is, the usage of composites materials is expanding its wings for various sectors, various applications. That includes your aerospace, automotive sectors, as well as other kind of domestic products manufacturing sectors. So automatically the classification of composite also brought in such a manner that today's discussion, I'm going to share about the which kind of research we can do and which kind of composites we go for making, especially by using the fillers. So what are all the fillers available? Which one we use as a filler? That is my major focus of discussion on this 1.5 hour session. So let me move on to the discussion about my topic. So this is the contents of my presentation. Once again, I am going to give you a touch about the basics of composites and the hybrid composites, why we go for hybrid composites, then what are all the different types of reinforcement materials we use in terms of producing on advanced composites, and what are all the various fillers we use. Fillers in the sense, since my background is a mechanical engineer, so my focus is towards the utilization of industrial waste as a filler. So here I am going to discuss detail about how we carry out research, how we carry out some interesting studies by using the waste as a fillers. Then followed by that, I am going to discuss with you with few case studies that I did with the help of my research lab members. And after that, exclusively I am going to discuss about one particular type of filler which is called by the name biochar. So my key point of discussion today is about the biochar, because this biochar is the very innovative one, recent one, and the earlier days it's used only for the agriculture purpose. Now for the past few years, and based on the research done by my lab members and with my collaborator in Sweden, we just came to know some excellent property possessed by this biochar, which is used in exclusively in the composite manufacturing. So that I am going to discuss with you as the second part of my this session talk. Then followed by that, brief introduction about biochar and how to prepare biochar-based composites. What's the need for that one? After that, I am going to again show you some interesting case studies and the results which we obtained. Then as a second part of my session, followed by that, I am going to conclude my presentation with a brief summary about what we are discussing right now in the first half and the second half. So this is about my presentation. Let me start briefly about how a composite is derived. Whatever the thing, 1 plus 1, that is one or more combination, we can't claim that as a composite. How a composite is derived means that two is going to bind together and they will possess some interesting property other than of this mixing two. For example, if you see this photograph, the first one is the matrix, and there are different types of matrix, as you all aware. Metal matrix is there, polymer matrix is there, and the ceramic matrix is there. Here I am showing one typical polymer matrix which is also called by the name resin. So the familiar type used in various manufacturing sector is thermoset and thermoplastic resin when it combined with the reinforcement. So this is your matrix. So your matrix when combined with the reinforcement, it's going to produce your final composite. The final product obtained is our composite material. And in the reinforcement, nowadays, the major focus is towards the utilization of natural source. As we all aware that now we are moving towards the utilization of natural source, which is available by nature itself. So that's gaining more interest in such a manner that nowadays the major focus is on natural fibers, which is available by nature itself. Nature in the sense we extract those fibers from the available existing plants, trees, etc., fruits also interestingly. And another one interesting thing I will point out, even our hair also has some kind of fiber content, human hair, animals hair. So lot of things naturally available source we are going to use as a reinforcement. Apart from that, the synthetic fibers also creates interest. The reason behind that is synthetic fiber is obtained by means of undergoing some kind of chemical reactions by mixing few chemicals together. The synthetic fibers are extracted. Now that also the focus is on that also. What's the reason is because of the excellent properties it possesses when compared to few natural fibers. So the synthetic fibers also play a role. And the example for these natural fibers and the synthetic fibers, few examples I would like to point out. First of all, I point out the example for natural fiber, which is your banana fiber from the banana plant, sisal fiber, and pineapple fiber from the pineapple leaves. Likewise, the leaf, the list will go on. Then, in the case of synthetic fiber, of course, very well known to us, the first one is the glass fiber. Then, followed by that, in the recent years, the focus is on the usage of basalt fiber. Basalt is another excellent synthetic fiber which overcomes the strength of glass fiber in many occasions. So this basalt fiber is extracted from the basalt volcanic rocks. So these are a few examples for your synthetic fiber case. So when we combine together these two, the output one is your composite material, which should be in a plate form or whatever the product form as according to the mold we are going to use and according to the application where we need. Okay, so this is about the brief introduction about how we are deriving a composites. Followed by that, the next one which I would like to discuss with you is about the hybrid composites. So why we go for hybrid composites? Since we all know composite is one or more in the sense matrix and reinforcement. Now, as the technology changes, as the day progresses, and as more research is evolving, the usage of hybrid composites comes into picture. What's the hybrid composites? Here you are going to use two or more reinforcement instead of one reinforcement and one matrix. We go for using two reinforcement. On the other hand, two matrix is not at all possible. There is no enough research is there because of its chemical properties. Two matrix is not at all difficult. I mean, it's a difficult task. But on the other hand, our research team, we focus on mixing fillers with the matrix in such a way that we are able to produce the hybrid composites. Because what's the reason? Here the reason is one matrix is there, one filler is there, and another one is the reinforcement is there. Okay. So this is about your hybrid composites. If you note the picture here, this white color I mentioned, that is one type of fiber. Then this yellow color is the next type of fiber. Now two fiber I am going to compare, okay, and this two fiber I am going to use as a reinforcement along with the matrix. So this is said to be as the hybrid composites. And as shown in the picture, instead of using two fibers, we can use one fiber, and along with that matrix and fillers we can go for. That also said to be as the hybrid composites. So as my today's topic discussion focus is about the fillers, I would like to highlight you all that these fillers will be used for producing on effective hybrid composites. Okay, and this hybrid composites we are able to produce by using continuous fiber as well as discontinuous fiber also. And the arrangement, the different types of arrangement is shown in the figure. For example, if you take the continuous fiber, the first one interlaminate. So this one is the one type of fiber, and the yellow color is the next type of fiber, where the two fibers are arranged one above other like this. And in the case of the second type intraplay, you see the yellow colors, it's scattered here and there. If you see, you are able to notice the yellow color here and there. Okay, so that's your next type of arrangement, making the hybrid composite. See the next picture, it should be well understood. Then the third one is the intermingled. If you notice the intermingled type, here what's the thing happening now? The two type of fibers, they are scatteredly arranged, they are intermingled together like this. So this is the way how the continuous fibers are arranged. In such a manner, the discontinuous fibers are arranged either in a random way or aligned way as shown in the pictures. So this is about the brief introduction about hybrid composites, how we can prepare hybrid composites in different arrangements. That's what clearly shown in the pictures. Now, why we need hybrid composites? Of course, this question will arise in all our mind. Automatically, composites will reach the peak, and more sectors they are using composites. Why specifically we go for composites, and why we go for fillers? Okay, it gives the answers for that also. Why we go for using fillers for making some advanced composites, interesting composites? The first reason is general thing, that is about the cost factor. High material cost is there. We go for merging one or more fiber, or fiber with filler, or matrix with filler. Now, this one automatically gives some excellent output properties, enhancement in properties. So, if you use filler as as a material which is available by nature itself, there is no cost involved there. In such a way that instead of spending a high material cost, with a very, very low cost, we are able to produce some good, interesting, advanced composites. That's the first reason. The second reason is the low installation cost. There is no special setup you are going to introduce for making your hybrid composites. So the installation is zero ultimately. So that's another advantage where we go for the hybrid composite. And another special property possessed by means of hybrid composites is they are non-corrosive and they are still lightweight, and no special fabrication is needed. Just as usual, you go for using the type of techniques which we are using for the normal composites. That's another one main thing. And maintenance, in terms of maintenance also very, very low, no cost involved. Okay, and the ultimate one highlighting point based on which we go for the hybrid composite is the high strength equivalent to our existing conventional materials. So these are all the major reasons based on which we go for the usage of hybrid composites. Let me move on to the discussion about a few examples. In my next two slides, I'm going to show you few interesting examples about the different reinforcement materials we are using and the different matrix materials we are using. Okay, and so this photograph shows some interesting natural fibers as well as synthetic fiber, which is used for developing advanced composites. So the first one is the coconut tree. From the coconut tree, this is the coconut seed extracted from the coconut tree. Then this one is the sisal fiber. This sisal fiber is purely a natural resource which is grown by itself. Okay, and in nowadays homes also they are keeping the sisal plants as a decorative one like that. Okay, so the fiber extracted from sisal plant is like this, just like our hair with the pale brownish in color. Then this is one example of the synthetic fiber, your glass fiber, which is in the matte form, and you can cut the mat and utilize that one according to your need. So these are all the different type of some few examples of natural fibers and the synthetic fibers which we are using effectively for producing the advanced composites. And here, apart from these picture shows additional natural fibers we are using are Kevlar fiber, boron fibers. Okay, then from flax, hemp, jute, straw, wood, rice husk, wheat, barley, oats, rice, sugar cane. Interesting thing. See, sugar cane and from the bamboo plant, as well as from our grass also, kenaf, rami, palm fibers, coir, water. So lot of exhaustive, as I told you, banana, pineapple, lot of exhaustive types of natural fibers are available there, which is used as a potential reinforcement for making your advanced composites. And the main role of your reinforcement is it adds strength to the matrix. That's the main purpose of your reinforcement material or functions of your reinforcement material. And the types of matrix we are using normally is the polymer matrix, metal matrix, as well as ceramic matrix. That one you choose depending upon your applications. Okay. Nowadays, the research is going on in a mixed manner. That is, up to a few years back, researchers they produce composite material by using natural fiber along with the polymer matrix only. And the output is they are producing polymer matrix based composites or in some cases biocomposites also. But and metal matrix where they are going to use now, they are going to use the metal matrix exclusively for producing products related to your aerospace sectors. Okay, where the metals is involved and the two metals joined together, reinforcement and the matrix both will be a metal. But in the recent day they start reinforcing and doing the research studies on reinforcing your natural fiber with the metal. So that research is going on as a recent one, where some exhaustive research will be needed in the coming days. So this is about the various reinforcement and the matrix materials we are using in manufacturing the advanced composites. Now, the next one I am going to focus is about the major fillers which we are going to use to produce on our advanced composite materials. And these four are the major industrial waste, the industrial waste collected, and they are ball milled and the fine powder form is shown in the pictures. So these four are the very commonly generated industrial waste, more in number. Okay. So our our team members did some extensive study on using these industrial waste as a fillers. Okay. And this rice cuts is the waste produced during the processing of wheat. Okay. And the fly ash, of course, you all are aware about fly ash. In all the industries, while banning fly ash is generated in more number. Then the third one is the red mud. This is an interesting waste. And myself and my professor Udaykumar, we completed one sponsored project based on this red mud utilization only. That is, what is this red mud? Now, it is an exclusive waste generated during the production of aluminum. That is, it is the waste coming out from the aluminum industry. So this waste we are using as a filler. That is, we are going to recycle. And from this, we are producing some innovative composites with excellent properties. Then finally, sawdust. Of course, we all know about sawdust, which is also another waste generated during the processing of wood for making doors, windows, and other panels. Okay, so these four major ways we take as a filler, and some interesting results they produce during the making of composite manufacturing that I would like to discuss with you in my coming slides. So first of all, how we prepare the composite means, here we just take the polymer matrix, because this type of fillers have the capability to bind only with the polymer matrix, not with your metal or metal. You can try. Okay, because without trying we can't say anything. You can try in such a manner that your metal or ceramic should be in the powder form, because as I shown in my previous slide, all these are in a fine powder form. So you have to collectively mix it together, and you go for some advanced powder metallurgy technology that I am not familiar. If you are familiarized in those area, you can try that also. Another interesting results you are able to obtain, you are able to notice. So that I would like to point out here. So by means of those industrial waste, we just take the waste as a filler. Okay, and now we are going to reinforce this filler along with the polymer matrix, which is none other than unsaturated polyester, because your polymer matrix itself is a big family. Polyester, vinyl ester, epoxy, polypropylene, like this number of interesting type of polymer matrices are there. Okay. So here we take the unsaturated polyester and we mix the waste with the unsaturated polyester, and we produce the three type of composites based on sawdust, fly ash, and the specimens prepared is shown here in the pictures. Then, as I pointed out, as a mechanical engineer background peoples, we just carry out the mechanical property studies, which mainly include the tensile strength, flexural strength, and impact strength. And we take two polymer families, how the wastes are behaving, how these fillers are behaving. So for that, the two families we have considered. One is both belongs to polymer. Okay, I'm sorry, both belongs to polymer family. In that polymer family, two waste we have taken. One is the polyester, another one is the epoxies. So now here, the interesting results that we obtain is tabulated here. Here the I indicates the increase, and all the values is in terms of percentage, the increase and the decrease in strength in terms of percentage. Now, do you note, in the case of sawdust waste, both polyester and epoxy shows a considerable increase in all the strength except this one particular case. In all other case, if you note, 14% increase, 11% increase, 61% increase. So in the case of polyester, all shows the increasing trend. Okay, if you see overall collectively all the four waste, you are able to notice only the increases. In this particular case, only decrease. Probably they don't have enough capability to withstand the pulling force. Okay. On the other hand, in the epoxy also, most cases increase is there, but decrease will be in the high trend. So this waste not at all more compatible with epoxy, because we are able to notice a drastic decrease in the mechanical properties, exclusively your tensile, flexural, and impact property. So this, when compared to polyester, epoxy is not good compatible with your, I mean, fillers, the industrial waste of the fillers. On the other hand, the polyester poses increase in all the strength, and you see in the fly ash, rice husk, sawdust, all these three waste shows increase in the weight percentage in all the three cases, that is tensile, flexural, as well as impact. Only in the case of red mud, that also we noticed in the case of red mud, the non-uniform distribution of these fillers will produce a decrease in the tensile strength, because the fillers accommodate to one particular base. Here, your filler is the reinforcement. During my earlier slide presentation, I point out to you one thing, that the reinforcement main purpose is to give additional strength to your matrix. So if the filler occupy one particular position, simply your matrix will remain in one area. So now your matrix not get strengthened. That's the thing happen because of the non-uniform distribution, which results in the decrease that we noticed in that particular case. Other than that, we are able to notice an interesting increase in the strength. So now this results I am showing purely for your filler and matrix. That is, the filler is the reinforcement, and the matrix is your polyester and epoxy matrix. Now, with this, let me move on to the discussion about the case studies. That is, a few examples I am going to take, and how the advanced composites are manufactured, and how it behave with respect to the usage of your fillers. Okay, especially the industrial waste fillers. So let me show you the case study 1. So this is the case study 1 about the hybrid composites prepared purely by using your natural fibers. Here, the results I am showing in my case study is for the combination of two natural fiber. This is natural fiber 1, Palmyra waste. The next natural fiber is coir. So now this Palmyra waste and coir, they are going to be combined together, and they are going to be reinforced with the unsaturated polyester resin in such a way that the hybrid composites is produced. So here also we note some interesting change in the mechanical property, that is in the tensile strength, flexural strength, and the impact strength. Tensile strength, flexural, and the impact strength. That is the first tensile strength. This two waste, and another one main thing that we have to notice when we go for preparing the advanced composite is the composite weight percentage, and I mean not the composites, the reinforcement and the matrix. The reinforcement matrix weight percentage and the reinforcement length, all those things we have to consider. So here, if you note the graph, the first ratio is 20:80. That is 20% Palmyra waste, 80% coir. The next one is 30 is to 70, next 40 is to 50, and the last combination is 50 is to 50. So among these different four type of composite combinations we made, in all the cases, we are able to notice the enhancement in strength. So in the first case, tensile strength, the highest strength noticed in the combination of 40 is to 60. In the case of flexural strength, it is noticed in the case of 50 is to 50. In the impact strength also, it is noticed in the case of 50 is to 50 combinations. Okay. And if you notice that the graph is not in a uniform trend, you see that the graph, that there is a lot of fluctuation, lot of deviation in the results. One combination increasing, one combination decreasing, another combination decreasing, another combination increasing. So it makes the researchers to think differently. How to think differently now in terms of the manufacturing process, because this kind of results will purely based on the different combination, different composition we are using, as well as the, I mean, the defects also we can point out, the defects in the manufacturing process. So here we change the fiber length also 3 centimeter and 4 centimeter, and the higher fiber length which will possess the highest strength. That is noticed from all the graphs. That red color is the highest fiber length of 4 centimeter, and compared to 3 centimeter, this 4 centimeter possess some good results. Okay, so flexural and impact 50 is to 50 is the weight percentage which possesses enhancement in results. On the other hand, tensile strength, the 50-50 is coming as the last one. Okay, only 40 is to 60 is having the highest value. So this again may be due to the incorporation of your Palmyra waste and coir in such a way that we are not able to obtain the final product in a proper uniformed manner, in such a way that high strength is effective there. So this is one case study. And this is the next case study. What we did is, now we just did one thing in such a manner that we add a filler along with the fiber and matrix in such a way that case 2 is the another type of hybrid composites we prepare. See, my case 1 is purely the preparation of hybrid composites based on 2 natural fibers. Okay. Here, in the case study 2, I am going to discuss the behavior of hybrid composites prepared by using your fiber, then filler. The filler is the industrial waste red mat as mentioned in the table. Then followed by that, your matrix is the unsaturated polyester. And here, we just vary the weight percentage of the industrial waste red mud filler from 2 to 10 only. What is the reason? Why such a low weight percentage is selected means? The reason behind that is, during my initial studies and during our initial iterations we carried out, and from the iterations we are able to notice that the higher addition of weight percentage will decrease the strength. So we just turn our research focus towards the preparation of development of advanced composites using low weight red mud percentage that varies from 2 to 10. That is the reason why nowadays the nano composites is creating a huge impact, because the nano composites, the size is of course in nanometer, microns or nanometers. So which will give you a better surface dispersion. So if the surface dispersion is more means, then automatically we are able to obtain more fine results. That is evident from many researchers carried out. Okay. So because of this reason, we choose this small range particle that I would like to highlight here. And of course, you notice the strength. This is the one without the filler. See here, the percentage is 0. So this is the one without the filler. The strength is 79.63. If you take the other cases, the increase in the strength is noted, except in the case of red mud 8 and 10. So you see that the increase in the weight percentage is going to decrease the strength. That's why we choose that range between 2 to 10. Okay, so among the combination, the 4 weightage percentage possess better results. In the case of the red mud particle size 13. So if you vary the particle size of the filler, that will also create a huge impact on your strength. Okay. That's a 4 micron meter particle size. It's going to give a highest strength of 89. That's for the 2% only. Remaining all the percentage, it gets decreased, and it is slightly increased for 8 and 10. Okay. The reason will maybe due to the occupancy of your Redmond's dispersion. Then followed by that, the flexural strength also behave in such a manner. And the impact strength results also shown in the table. So from these results, what I would like to conclude and what I would like to insist strongly is the addition of the Redmond filler along with the natural fiber and polyester resin will produce a increase in the mechanical property, that is increase in the tensile strength, flexural strength and impact strength. Just for that, I will take one example. I will change the color, green color. Now please note the green color marking. This case 92, and the next case among all, this is the highest one, 501.77. Then here this case among all, this is the highest one. Nearly 22 is the highest. You can take anything. This is the almost highest one. So if you see, when compared to 0 in all cases, now compare the 0 in all cases. So while comparison, it is going to produce a much better improvement in this strength. So that the 0% is only your fiber and matrix results, fiber and matrix combination results. On the other hand, if we include as a secondary reinforcement for producing the hybrid composites, the enhancement of strength is noticed in all the cases, that is tensile, flexural and the impact properties. Okay. And this is the small comparison about another kind of hybrid composites produced using your industrial waste along with the 2 fibers. See, this results is for 1 fiber along with the industrial waste filler and matrix. Here you notice 2 fibers. First one is the sisal and the glass combination. One natural, one synthetic is taken. Then this is compared with the sisal, glass and the RM is your red mud, the industrial waste filler. In the same way, like sisal glass, BS is the combination of banana sisal, that is both natural fiber. So this banana sisal natural fiber composite is compared with banana sisal red mud composite. Now you notice the peak. Please notice this color. These 3 colors will go in a increasing trend in the case of your addition of filler. So in all the case, interestingly, if you notice that the increase in the mechanical property values is clearly identified. Okay. So this concept is going to produce a huge impact in the case of your polymer matrix, where enormous research is done, exhaustive research done using polymer matrix in the hybridizations. Okay, and you can select any one of the combination of I mean, as mentioned in the slide, this I'm sorry, banana sisal combination or glass sisal or glass banana, okay, or oil palm banana. So these are all some of the interesting combination: pineapple glass, coir glass, jute flax, sisal red mat, bamboo fly ash. Likewise, all these kind of hybrid composites are produced, which produce a better performance of better performance composites, and a lot of works earlier itself reported by many researchers, and especially for the hybrid concept, they use this glass fiber. Okay, that I would like to highlight you. Okay, so with this, I am concluding my first part of presentation, and as I pointed out to you in the beginning slide, let me move on to the discussion about my the last half. The second half of my presentation is about another one interesting type of filler, that is about the biochar. Okay, so now I would like to wait for any questions. I also have some water. We have another half an hour still, 30 to 40 minutes left out. So that time I discuss my second half. So in the meantime, if you have any clarification till this, kindly ask your questions. Let me have some water also. Okay. If there is no questions, you can post in the chat box also. I will check the chat box also. Okay. Okay, let me continue my second half of my talk. Okay, later on we will have the discussion. I will take another 20 minutes to 25 minutes for the discussion of my second half, and followed by that we have the yes sir.
Sir, when you are taking different combinations, jute,
Yeah.
sisal, so like that.
Yes sir.
Sir, so what is the volume fraction of each fiber you are taking? So in this, anyone is constant, or you are taking so different volume fractions for all these combinations?
Yes sir. Yes sir. Good question, sir. Actually, we just fix the matrix volume percentage as a fixed reserve, and only we vary the reinforcement weight percentage. That is, we vary the sisal, we vary the glass fiber, as well as the filler also. Okay, but in this case, in this particular case, we fix two as the constant. That is the matrix and the fillers are 10%. Okay, but we vary the natural fiber weight percentage, sir. That is sisal and the glass we varied. And in my earlier case, I mentioned in the slide itself, sir. Here we keep the matrix and the fiber percentage constant here, sir. Okay, and we vary the filler weight percentage in this case. Okay, and in my previous case, I mentioned that is 20:80, varying the two fiber weight percentage and keeping the matrix weight percentage as a constant fixed one, sir. Yes, sir.
Sir, if you are varying two hybrid, in case of hybrid reinforcement, if
Yes,
you are
yes.
varying, so your two fibers volume fractions, so simultaneous, what happens means, so you know, so which one affects the strength and which one, so due to, so which fiber, so having so more strength you are getting or not, how you can say?
Yeah. Sir, that's another one good point. I would like to insist you here that for the main reason only, initially we take, for example, the sisal as 30%. Then the banana fiber as remaining 70%, 30 is to 70. So in the 30 is to 70, we just study the mechanical properties for this combination. Okay. And now we keep this 30 is to 70 as a fixed, and we add the reinforcement. Okay. We add the filler reinforcement along with that one. So we had the comparison values in our can. Okay, already based on the pure sisal and pure, banana, we have the results. So based on the results only, we are able to compare. And apart from that, as you pointed out, we are not able to, identify if we vary that combination, which one is exclusively affecting. And along with that, if you go for the characterization studies using the scanning electron microscopic or some advanced studies, you are able to notice, differentiate the two fiber presence. And based on that also, you are able to identify, because you are using one fiber in matte form, another fiber in short fiber. So at that time, you are able to identify that easily based on the characterization studies. That will help you more effectively. Okay.
Sir, one more doubt. So when you are using the red mud,
Yeah. Yes.
so what happens means, so tensile strength increasing up to some 6% or 4%. So whereas if you are using 6%, what happens means strength, tensile strength decreases.
Yeah.
So
Yeah.
why?
Yeah.
So it causes, sir. Why? So it decreases. Is there any reason?
Yes, yes, sir. Yes, sir. What's the main reason is uh, that one we are able to do by means of solution dispersion method, sir. That is the manufacturing technique which we followed in preparing that red mud and the polymer, red mud based polymer composite is solution dispersion technique, sir. This one. So in the solution dispersion technique, it is simply like your can layup method. I am having one glass mold, and in the glass mold, I am going to pour my polyester, my polymer, either polyester or epoxy. Okay, and that one red mud which is in the powder form, I am going to put it in the polyester matrix or epoxy matrix, and I did manual stirring. So the reason is due to these manufacturing techniques. Because of the manual steering, the proper distribution of redmond is not there, and also I am going to manually pour in the glass bowl. So during the pouring also, what the thing going to happen now, the distribution of red mud is going to accumulate one particular place here and there. It occupies the corners. So that's one of the reason we identify as a major thing for the variation in the strength. So better, in order to avoid this kind of defects in the techniques, we must go for other things, like instead of going for mechanical steering, sorry, manual steering, we go for mechanical steering. The mechanical steering will provide a very good uniform distribution. I mean, mixing of your red mud with the polyester matrix. So that's the major reason which we identify.
Okay. Thank you. Thank you.
Yeah, yeah, thank you, sir. Thank you for your nice interactive questions. Okay, fine, sir. Now let me move on to the discussion on my last topic quickly. And this one is about the biochar, which is another interesting type of filler which we are working more recently. For the past, 2 to 3 years, my research team is doing some work research on this area. Okay, what's the biochar? Biochar is nothing but it is also the one which is prepared from the waste, and it is going to obtained from the waste when your waste is going to subject to the pyrolysis process. Okay, what do you mean by pyrolysis process? In the sense, here during the pyrolysis process, the thermal decomposition of biomass we are going to do in the absence of oxygen. That is, there is no oxygen present. You are going to put your waste inside a container, and in the container, the waste is subjected to burning. in such a way that absence of oxygen is ensured. Okay, and this kind of biochar produced will have an excellent capability that it has good content of carbon, and automatically if there is a presence of carbon is there means it will enhance the properties of your composites drastically, and especially along with your polymer matrices. And this is the pictorial, you see, this is the first one. We all known about this one, that is our corn waste, that corn cob. So after the using of this corn cob, the remaining waste, this is the waste we all familiar. This waste I am going to collect and I am going to crush like this, and I am going to subject this waste to the pyrolysis process. At the end of the pyrolysis process, I am able to obtain a biochar that's having high carbon content, good carbon content is obtained. So this is what I pointed out. That is the GMAS crop, which is a popular agro waste. See, one interesting thing I would like to highlight: you can extract biochar from medical waste, from industry waste, from agricultural waste. More options are there, more openings are there, in such a way that by means of the biomass concept you are able to produce an effective biochar. So here I am showing you the case regarding the biochar produced by using your corn cob waste. Okay, and this biochar is ball milled, and they are going to produce uniform sized particle, and this one is going to again used as a filler, as a secondary reinforcement along with our natural fiber for producing the advanced composite. So quickly I will go through my slide. So this is the elemental analysis and the interesting thing, the composition present in your biochar. This is your ordinary waste corn cob. So your ordinary waste corn cob has a carbon percentage of 47, whereas the biochar obtained from these corn cobs by means of the pyrolysis process have a very high carbon content of nearly 78 percentage is there, which is a very high content that will make your this corn cob biochar as a effective reinforcement for making some advanced composites. Because as we all know, carbon is one of the highest strength. If the carbon content is there means it surely produces a highest strength. So this is how we are producing the biochar. The source is from corn waste, and the pyrolysis temperature. This temperature normally it should be varied from 500 to 700. You can take 500, you can take 300. That one depending on your waste material. Okay, because this 700 is suitable for corn cob. Some cases this 700 will not produce your biochar. So depending on the material, the temperature will vary from 300 to 700. And the duration of burning is normally 3 hours in a closed confined environment where there is a complete absence of oxygen is there. So after the content is obtained, it is subjected to ball milling, and the ball milling is normally it should be in the ratio of 1:15 to obtain a smooth fine powder form. And this is the ball mill speed and the hours duration. That also vary depending on your material. So after the biochar is prepared, it is subjected to various characterization studies to understand the various composition elements present in the biochar. So for that, normally you can go for a SEM, EDAX, XRD, FDR studies, as well as particle size analyzer also, to know how much size your biochar is there. All those things you are able to understand by means of this characterization study. So this diagram shows how we are preparing, extracting the biochar. So the first one is the matrix, which is as usual, the polyester matrix is taken. Then the reinforcement is your biochar. See here, this black one is none other than your biochar. And this is your solution dispersion method, which is pointed out a few minutes back. This is a glass mold, and the glass mold covered all the sides except the top sides. Okay, and through the top opening, the mixing of your matrix and the reinforcement is poured over the glass mold, and the glass mold is left for the curing, and your final specimen obtained in a rectangular or square form depending on the size of your glass mold we obtain like this. Then further studies, you have to cut the specimen as per the AIM standard to carry out the various mechanical performance, as well as lot of studies of the physical property, chemical property. See, your composite is a very vast field, a very vast interdisciplinary approach thing. So you are able to use that one in a effective manner. And these are all the results which we obtain by the usage of biochar. So here, instead of in the previous diagram, I shown polyester. That one polyester is in, but the results we did using another interesting type of polymer, that is the pure vinyl ester resin. We are taking as the matrix, and here biochar is used. You note the difference here. This is pure vinyl ester. Pure V is the pure vinyl ester resin. So when compared to pure vinyl ester, the addition of biostar produces an enhancement in results in the 6 weight percentage. All other remaining weight percentage shows the decrease in this strength. If you notice the 6 weight percentage in all case, see here also the enhancement in strength is noticed. Here also the enhancement in strength is noticed for 6 weight percentage. So among all the combination, the 6 weight percentage biosar possesses excellent mechanical properties when compared with pure vinyl ester. Okay. So this is the proper example for composite. You must ensure yourself that when matrix and reinforcement combine together, it will produce an increasing strength at one point. Then only it's said to be as a composite. That it's going to produce some improvement in results. When combining these two together, it always produces a decrease in strength. There is no use of saying that one as a effective composite. Okay. So these are all the results I would like. Then followed by these interesting results we obtained using vinyl ester and biochar alone. We go for now mixing the biochar along with the, how it's going to behave with the natural fiber. So here the natural fiber we have chosen is the Sansevieria cylindrical fiber, and some of the special properties of this natural fiber is mentioned here. It has a high strength to weight ratio, it has a high creep resistant capability, high tensile strength, toughness also very good, and it has very, very high wear resistance similar to your metals, good corrosion resistance. Okay, and it's not affected by means of your temperature change, because of the temperature change, it is subjected to deformation, most of the natural fiber. That's not the case of your Sansevieria cylindrica. Okay, so this is the combination how your Sansevieria cylindrica is possessing some good properties, and how its composition is very when compared with other natural fibers like scissor. See, the Sansevieria cylindrica also we are using as a decorative plant. Okay, and this is the sum. Just I will quickly go through this one to clarify you what are all the composition present. You see here the elemental composition of the biochar, 85% of carbon content is there, which is a very, very good, and the peak also indicates that same one. And this is the same image of your biochar, which shows the presence of your biochar. And this is the XRD analysis that we carried out, and by means of the R test, by means of the R value we got, we are in a situation to ensure the presence of high carbon. So to ensure the presence of high carbon only, we carry out this XRD analysis as well as the FT, R test, sorry. Okay. Then these are the FTAR. Here also the peak possesses the presence of alcohol and phenol structure, which indicates the there is. All these tests are to confirm, to ensure myself that more carbon content is present in the biochar. Okay, and this is the characterization done for the Sansevieria cylindrica, and we go for fiber treatment also. That may be later on other sessions, other expert members will share you. So I don't want to spend more time exclusively on these. Characterization treatments. Okay. This is the FTIR for the treated fiber, NaOH and silane treated fiber. Yeah, let me explain further, explore my discussion on this topic, that is about the mechanical properties of the biochar filled Sansevieria cylindrical composite. That's the short form. And you notice here, again, as we pointed out, as we discussed in our earlier presentation, here also the 6 weight percentage composites show some interesting results. That is, the results is very, very high in the case of your 6 weight percentage biochar added Sansevieria fiber composites. That is here, it contains your natural fiber. See, this 0% without your biochar addition. Only Sansevieria fiber and the vinyl ester. So its strength is nearly around 45, equivalent to 45 megapascal. On the other hand, the addition of biochar, especially the 6%, so you see how much it increased the tensile strength. It touches up to 75 nearly. So that much high strength your addition of biochar yields. Okay. On the other hand, higher weight percentage, the strength gets decreased. Okay, which is ultimately evident from the graph that shown here. Okay. Now this is about your tensile behavior of how biochar behaves regarding the tensile strength. Now let me move on to the discussion about the next one, that is about the, the flexural. And this is the supporting evidences how the strength is improved and decreased, as I pointed out you, with the help of some characterization studies. I am able to monitor clearly. I am able to represent in a detailed manner at which percentage the weight percentage is increasing. Okay, that is the first image is shows for the 0 weight percentage biochar, where there is no matrix settled is evident from that. On the other hand, 6 weight percentage biochars, the fibers are fully covered with the matrix material. So the fillers and all those things holded strongly here, okay, which gives a good bonding nature. So because of the good bonding, ultimately the strength gets improved a lot. That's the reason. Okay. Then in the flexural also the same thing. See the increase again in the 6 weight percentage addition of biochar. So the good mechanical strength, why it is obtained means because of the high porous nature of the biochar. That's another important speciality of your biochar. So which plays a vital role in achieving a good mechanical strength. Okay, in such a way that we are able to attain a enhanced mechanical strength in all the cases. So that's the one thing that I would like to highlight you all. Okay, regarding the your flexural properties. Then followed by that, again few semi images. Okay, where here also the 6 weight percentage is shown. This is the 6 weight percentage addition biochar. See, this semi image I am going to take for the fractured specimen, and I am going to notice the fractured portion alone, how the fracture takes place. So by means of doing some extensive microscopy studies at the fractured surface, I am able to notice whether my matrix gets debonded or gets fractured, whether my fiber gets fractured, whether my filler gets collapsed. Everything we are able to notice clearly, exclusively by means of your, with the help of your scanning electronscopic studies. So in these scanning electron microscopy studies, I am able to notice that 6 weight percentage biochar has a strong interfacial bonding between your matrix and the filler that will automatically hold the fracture. That will automatically hold strongly in such a way that the fracture gets avoided, the failure gets avoided, which is evident from the same image. Again, same case, the 6 weight percentage, your impact strength touches the peak, Okay, and the increase is about 42% higher than the one which is without the biochar. Yeah, and with that, the mechanical properties is over. How the mechanical performance is improved a lot by using your biochar filler along with the natural fibers for producing some advanced composites. In the same way, another two, three properties I'm going to highlight quickly. That is, the first one is about your erosive behavior. This is one interesting property where the recent studies on composites is focusing on. That is about the erosive performance of polymer matrix composites. So the erosion studies carried out by using a special setup called as erosion test rig setup. And in that, the three variables which we can vary and study the composite performance is the filler content, the impact velocity, and the impingement angle. Okay. Now these are all the variations. So here also we are able to notice that by varying the biochar weight percentage from 2 to 10, again the 6 weight percentage biochar produces. Not 6 weight percentage. Here with the increase in weight percentage, the erosion resistance is very, very high. Okay. So that's ultimately evident from the graphs. Okay. These are all the uh, supporting scanning electron microscopic studies, where we are able to notice that addition of biochar to the sincera silica fiber will make the composites, will behave the composites from ductile to semi-ductile nature, and it's going to remain in the semi-ductile form from 2 to 10 weight percentage biochar content, and an increase of 68% in the erosion resistance is noticed for 10 weight percentage. That's why with the graph I pointed out to you, here it is not the case. Here it is not the 6 weight percentage. Here it is the 10 weight percentage. Because of going higher weight percentage, the erosion resistant also high. Okay, so here it's for your 10 weight percentage biochar. And the next property which we study for the biochar based Sansevieria cylindrical composites is your water absorption test. So moisture absorption studies is carried out with a main focus on understanding the moisture resistant capability of your developed composites, and the moisture resisting is evident from the simple calculations which we did based on finding the diffusion and permeability coefficient. How I am ensuring? So if you see the table, D is the diffusion coefficient, P is the permeable quality value. These two, the formulas are available in many researchers already used. So that one we follow, and we study, we find the moisture absorption resistance. So by means of D and P values, we are able to notice how the composites is behaving to moisture resistant. So here what's the thing is, the coefficient is going to increase for the case of 6 weight percentage. So from 2 to 6, it's going on in the increasing trend, the values. If you notice the table, after that, there is a decline. See, 1.9, then it starts declining from 8 to 10 percentage. That is, both these parameters starts falling because mainly due to the excess concentration of biochar, which starts absorbing more water. Okay, and also another main reason they are pointing out is due to the presence of salt content in the seawater, the absorption coefficient is considerably less in the case of your seawater in terms of, okay, and also the salt present in the seawater disables the easy filtration of water molecules into the composite. So we consider three cases: seawater, groundwater, and distilled. And higher the value of diffusion coefficient will always shows the better resistivity of the composites under immersion, which is the very highlighting point that all of us must be aware while doing the water absorption test. Then the last test that I would like to discuss with you for another 2-3 minutes is the chemical resistant test. So we subject the prepared biochar-based natural fiber composites to acids, alkalines, and solvents. Both taken in two numbers. Two acids is taken, which is as noted in the table, that is HCl, hydrochloric acid, and hydronitric acid, HNO3. Then alkalines is taken, sodium hydroxide, and Na2CO3 is taken, followed by the two solvents taken is toluene and benzene are there. Okay, so these are all the various acids, alkalines, and the solvents we have chosen to carry out the chemical resistant test. And interestingly, what we note is the addition of biochar based composites, it shows a weight gain in all the cases. That is, it has the capability to absorb the chemical. So a weight gain is noted in all the cases, and which clearly indicates that the composite is not going to lose any weight. Okay, as like the situation in our erosion studies. So same like our erosion studies, here the composite does not lose any weight, which shows an interesting phenomenon. Okay, then with this, let me move on to summarize the things what I discussed right now about the biochar as well as my starting discussion. So I start with I start my summary with the recent one which we discussed, that is about the biochar. So biochar is extracted purely by the pyrolysis process, and the example I have shown here is extraction from the G-maize cob, and it is manufactured successfully by the solution dispersal method I pointed out to you, and the weight percentage we have taken is varying from 2 to 10 percentage. Okay, and here the interesting thing we noticed, as I pointed earlier, is increase in the tensile strength by 2 percentage, flexural strength by 5 percentage when compared with the pure vinyl ester. Okay, and among all the composite combinations we prepared, exclusively the 6 percentage weight addition of biochar shows some excellent results, which proved to be a potential filler in addition with the other natural fibers for making some interesting advanced composites. Okay, that's the thing. Then the next one I would like to highlight in my summary is regarding the improvement. So when we use biochar in the natural fiber, the better case where some good enhancement in the strength noted is for 40 mm 48 percentage NaOH treated fibers, NaOH treated fibers. Okay, and in this case, 6 weight percentage of biochar along with the 40 mm 48 percentage will possess better mechanical properties. Okay, where the influence of fiber content, fiber length, and the fiber treatment on the properties also noticed, analyzed in detail. And also this one I highlighted earlier, that is the erosion behavior. It changes from ductile to semi-ductile behavior by the addition of 2 to 10 weight percentage. And this is about the erosion resistance. 68 percentage is there, and by the help of scanning electron microscopic studies, you are able to justify the improvement in the strength. Okay, and also NaOH treated fibers shows the improvement in the strength in such a way that 43 percentage increase in strength in the case of seawater, in the case of your for other waters are noticed. Okay, then the diffusion coefficient also increases. Okay, in the case of 6 weight percentage, your chemical resistant also shows some good resistance to various chemicals utilized, and they kept under studied under for a time of 24 hours. Okay, so with this, let me conclude my today's talk about the importance of fillers in advanced composite manufacturing. And now let me ready to clarify the questions from your side. More willing. Thank you for your patient listening. Now, if you have any queries, you can ask We have another, I think, 10 minutes time is there.
Sir, how this biochar is different from charcoal?
Yes, sir. See, how the biochar is different from charcoal means 100% difference is there, sir. This biochar, uh, it's not going to be generated like a burning on ordinary thing from which we are able to obtain the charcoal. Here, this burning takes place in a confined environment with the absence of oxygen. In such a manner, the name is called as the pyrolysis process, sir, where we are able to create a controlled burning in the absence of oxygen and for a particular temperature only. If the temperature exceeds and not meet out the mentioned, the waste you are using, sir, it automatically becomes a charcoal. Okay, sir. So this is the notable difference, sir.
Okay, what is the size of the particle you are taking, sir?
Sir, we have taken the particle biochar of size 8 microns, sir. 8 microns, sir.
8 microns. Okay.
Yes, sir.
That's okay. Thank you.
Sir, generally, good
yes,
morning, sir.
good
Sir,
morning.
generally, you have used two types of resins. One is polyester as well as next one is epoxy resin.
Yes, sir. Yes, sir.
But in similar cases, epoxy resin has good mechanical properties when the experiment is done.
Sure, sir. Sure.
But you have shown in mechanical properties, in polyester resin, the maximum amount of percentage is increased more than that of epoxy resin.
Yes, sir. Yes, sir.
Which resin is good, and what type of epoxy resin have you used in this experiment, sir?
Sir, as you pointed out, automatically the epoxy resin is a high strength producing one. But the reason is the bonding of your reinforcement. In my case, the industrial waste has some properties, sir. So that property not adaptable to the epoxy. So that's the reason it just pull down the mechanical performance. Now adaptability in the sense that my mixing is not good. I am not able to mix uniformly properly my industrial waste with the epoxy when compared with the polyester, sir. That's why I mentioned that one in technical terms, the manufacturing process. Okay. So you can select your resin based on the compatibility, sir. That is one main reason. But at the conclusion, my point is, if you take pure resin case alone, epoxy is the highest one. Okay, sir. But you can try the compatibility. Okay, that's another thing. Yes, sir. So I hope I clear your question.
Okay, sir. Viscosity is more in epoxy, that's why you cannot mix properly. Okay, sir.
Yes, sir. Yes, sir. Yes,
Thank
sir.
you.
That's the reason, sir. You got that.
Okay. Okay.
So good morning, sir.
Good morning, sir.
So thank you for your brief explanation about various fillers. Okay, so it's really interesting, and you have highlighted some of the cases study, which is very useful for the research scholar. Thank you, sir.
Thank you, sir.
My question is, you have taken many fillers. How you dispersed with this filler with a matrix, sir?
Yes, sir. Sorry, Tyagi, sir. Can you please repeat, sir?
Okay, so how you will mix the filler with the resin, sir? Which way it is better?
Okay,
so
fine.
Normally
fine,
we have preferred the mechanical stirrer, or sometimes we have go for some sonication process also.
Sure, sir. Sure, sir. Sir, my based on my research team experience and based on my inferences, the best thing is, as you pointed out, go for mechanical stirring or other kind of some good processes which is existing. Okay, sir. Because during that time only, in the case of manual method, if you go for manual methods, sir, I mean manual in the sense can layup, sir. For can layup method, you go for mechanical stirring or other kind of methods which will most suit the mixing of your filler with your matrix, sir. Okay. Apart from that, if you go for compression molding, I mean, if you use a natural fiber nozzle, at that point I go for the compression molding, and that time also you mix your filler along with the matrix with the mechanical stirrer means surely we will get some improved results, sir. So that's the best one I would like to suggest you. Yes, sir. Hope you get my point, sir.
Okay, sir. Thank you, sir.
Sir, anything I would like to add?
Hello,
Okay.
sir.
Yes, sir. Yes, sir. Please, sir.
Sir, I have two questions, sir. See the
Yes.
chat box. Oh.
Yeah. I will look out. Sure, sir. Yeah. So my two questions posted from our one of our Mohit Beniwal. Some lights on applications of biochar. Yes, surely, sir. So you the first major application, how this biochar is evolved now, sir, in the agriculture field, for the agricultural purposes, they use this biochar as a feeding chemicals, sir. Instead of going for chemicals for feeding the agro lands, they use this biochar. And if you refer through Google Chat, many research papers are there, sir, based on the usage of biochar for agro purposes. And apart from that, from our sides, the usage of biochar is limited to areas where you can replace the conventional material by composites. That is, for example, you can take some automotive applications, not in the aerospace, but in the automotive applications, and for producing some simple domestic products, and for producing packaging related things, we go for using this biochar based composites, which is a recent evolving one, sir. Okay, its main first initial starting focus is on the agro ones, as I pointed out, but recently these are all the things we are using. Okay, and another question is what type of epoxy resin is used in this experiment? Generally, yes. I think I answered Kiran
You
Kumar's
answered that, sir.
question.
Yes, sir. Yes, sir.
And Harshdeep Bosar pointed out, yes, sir. Yes, that's what I am pointing out again and again, sir. That is, biochar is the recent domain where every one of you has to explore that one based on your own interest. Okay. Then next, another two questions. NK257. All available resins are renewable and non-renewable. How do we choose the best resin? Yes, good one, sir. That is, all the available resins are not renewable ones. Your resins are classified into two categories nowadays, sir. That is pure bioresins and non-bioresins. Your non-bioresins are this polyester and epoxy, all those things, vinyl ester, all those things. And bioresins nowadays, effectively, we are using our PVC, then polypropylene, okay, likewise it goes on. And number of researchers are recently, they itself developing their own resins called by the names biopolymers or bioresins. They are called by the name. So a lot of things is there. If you are basically a chemical background people, you have a very good option to do research in developing a new kind of bioresins, which other researchers, other peoples as an interdisciplinary approach, they will explore those things. Okay, that I would like to highlight here as a very good research beginning one. Then the second question is, which composition of resin and fiber percentage is best? 60:40 or 70:30 or 80:20 for a single fiber and hybrid? Yes, for the single fiber, sir, the combination is 40:60. Because if you take all the natural fibers, sir, most of the natural fiber, they possess some excellent property between 40 to 50% range only. Below that range, their strength will be lower ones in terms of mechanical property, chemical property, as well as physical properties. Okay, so my suggestion is going for the 40-60. You can change that range, you will obtain some interesting results. Hybrid fiber, in the sense, we can start with the 40 always, sir, since it is evident that all the natural fibers possess some good strength from 45%. you are able to explore that one from 40. That's a very good sign of combination using your resin and fibers. Okay, so I hope I answered all the questions put in the chat box, sir. If any other having, yeah, Mr. Arun Raj having one question. Is there any methods to do the composition? Yes, yes, yes. Composition in the sense, sir, you are asking about the chemical composition, sir. For knowing the chemical composition, we go for either XRD or FTA studies or that, sir. Or I'm not, maybe I understand like this. If you mention any type of composition, you can further add, sir. Okay, I will surely. So I hope everyone should explore, sir. This is a very big industry. I mean, interdisciplinary area. You can carry out physical property studies, chemical property studies. Even nowadays, as I pointed out, sir, biology people also started analyzing the decomposition studies on composite material. Where biology background peoples, biotech peoples, you can explore that one. So it's a very big interdisciplinary area where still a lot of things remaining is there, sir. And you can explore the life cycle assessment also. That's the recent one I am going to start with my research team member. Yeah, yes, Arun Raj, sir. Material composition as well as chemical composition, both you are able to carry out by means of X-ray diffraction studies or by means of FTR methods. Okay, and Mr. Kumaresan having one question. What are the methods used for retting process for natural fiber? Yes, natural fibers, of course, it's hugely subjected to moisture. The retting process normally we used is ordinary drying only we did, sir. Okay, not any other kind of retting process right now we carried out. Maybe through some literature you can get some more information. So, okay. Can we replace charcoal with biochar in canister? Yes, sir. That's a good question. That's a good question, sir. Yeah, surely, sir. Surely, based on some interesting results, you can replace that one. Surely, in the case of charcoal, we can replace biochar, sir. It's showing some interesting properties. Okay, so you can try. You can try that one in the automotive applications. Okay. So if you have any other questions, you can ask, sir. I am ready to share my views. So I hope this is. Yes, sir. Vijay sir, sir.
Yes, sir. Yes, sir. Participants, do we have any queries? Yes, sir. You continue, sir. Arumugaprabu.
Okay. Okay, so you have a very good time for the next 2 weeks. You will explore the things. It's a very vast area, and this FDP will give you more clear informations. And I hope, and if you have any discussions further, you can contact me also. I will. I forgot to include my slide. That is the only thing I forgot to include because of the sudden change in the schedule. So I will just mention my contact number and my mail ID. So if you have any queries, clarifications, you can please just contact me. I will share my screen with Jayakant, sir. I take another 1 more minute to share my contact details. Okay.
Yes, sir. Yes, sir. Yes.
Or I put it in the chat box, sir. So please refer the chat box, sir. I just share.
Sir, one query, sir.
Yes, sir.
All the facilities are available in-house in your university, sir, in your institute?
Yeah. Yes, sir. We have a separate center for composite material, and we are exploring a lot of things. And even I am having the erosion tester in my lab, sir. Okay. I am myself only the in charge. So any kind of erosion studies, you can contact me directly. Okay. I mentioned my mail ID and the mobile number, sir. You can approach me.
Okay. Thank you very much, sir. Thanks for the presentation.
Thank you, sir. Thank you so much. Okay, Vijayan sir, let me conclude.
Armun sir.
Yes, Taniyalasam sir.
This is Taniyalasam sir.
Yes, sir. Please, sir.
First impression is best impression. Like, so our Armun sir today, he has taken, he delivered a very good lecture without the disturbance of, all the times you are hearing no video, no audio. So it shows the 14 days going to a good experience for participant. I thank sir, Armun sir, for your wonderful presentation.
Thank you.
Short and sweet explanation, sir. The presentation slides also very nice.
Thank you.
Within time also we completed. That is a first impression. That's why I told first impression best.
Sure,
thank you.
Sir. My congratulations for this FDP to post a successful one. It's a very long term, so I thank the organizers for planning such a big event. Thank you very much for giving me this opportunity. See you all. Hope you can have any clarification. You contact me. We will meet in another good session. Thank you, sir. Thank you, Taniyalasam sir. Thank you, Vijayan sir.
Thank you.
See you all.
Thank you, sir. Thank you.
Thank you, sir.
The feedback link is posted in the chat box. Participants, please fill it. The next session will begin at 1:45 p.m. sharply today. Through the same link, please join us. Thank you. Thank you all participants.
Thank you, sir.
Thank you, sir.
Thank you. Thank you.